We're to our next complex numbers video, our third video for polar form. Now we know complex numbers can be written in either rectangular or polar form. In our Argand diagram, in rectangular form, we'd talk about 4 real and 2 imaginary parts. But in polar form, we talk about a modulus 4.47 and an argument 26.6 degrees. All right, in this video, what I want to do is explore how to multiply and divide in polar form. Now, these rules aren't provided on the formula sheet, so you do have to learn these tricks. Okay, let's start with multiplication. If we have a complex number called Z1 and we have a modulus of R1 and an argument of θ1, and we have a second complex number where we have a modulus of R2 and an argument of θ2, then to multiply the two together, what we do is we multiply the two moduli, R1 times R2, then we write down cis, and then we add the two arguments, θ1 plus θ2. All right, let's show you with an example. So here's the rule, and let's work out if we have our first complex number, W, is 4 cis 30, and our second complex number is called Z, 5 cis 80 degrees. We want to work out what is W times Z. So to work out W times Z, we multiply the two moduli, 4 times 5. We write down cis, and then we add the two arguments, θ1 plus θ2. So 4 times 5 is 20, cis, and 30 degrees plus 80 degrees is 110 degrees. Our final answer is 20 cis, 110 degrees. Second example, but this time we're using radians. So here's our rule. We've got our first complex number, 4.5 cis 3 pi over 2. And our second complex number is called V, 2.3 cis pi over 5. We want to work out what's U times V. So once again, we start off by multiplying the moduli, 4.5 times 2.3. We pop down cis, and then we add the two arguments, θ1 plus θ2. Now when I work out 4.5 times 2.3, I get 10.35. Then I write down cis. And when I go to add fractions with pi in them, I just ignore pi for a second. I grab my calculator and I add 3 halves plus 1/5. That gives me 17 tenths. And then I pop my pi back and write it as 17 pi over 10. So my final answer, 10.35 cis, 17 pi over 10. Right, what about dividing in polar form? So if we want to divide, if we have a first complex number that's got a modulus of R1 and an argument of θ1, and our second complex number has got a modulus of R2 and an argument of θ2, when we divide complex numbers, we divide the two moduli, R1 divide R2, we write down cis, and then we subtract the two arguments, θ1, take away θ2. And let's show you how to do division with one last example. So here is the rule, and we have our first complex number, 15.25 cis 3 pi over 2. And our second complex number, V, is 6.1 cis pi over 5. We want to work out what is U divided by V. So to work out U divide V, the first thing we do is we go R1 divide R2. So we divide our two moduli, 15.25 divides 6.1. We write down cis, and then we go θ1 away θ2. So we subtract our two arguments. So I get my calculator, 15.25 divides 6.1, I get 2.5. Then I write down cis. And again, when I do my subtractions with pi, I just ignore pi and I just go 3 halves, take away 1/5. That gives me 13 tenths. And then I go and write my argument back with pi to write 13 pi over 10. So my final answer is 2.5 cis 13 pi over 10. Right, well, a little bit to work on. Hopefully you can go away and practice these skills until they become more confident. Thanks for watching.